let's go to aromatic compounds. What is aromatic, guys? Aromatic compounds is the compound that is the hexagon, we call, and which has a 3 double bond in every other bonding, and we call it Kekulé structure. This is gonna be just the 3D structure. The 3D structure is trigonal planar. Rn is a term used to describe aromatic compounds. This double bond, the 3 double bonds that I said is inside this hexagon, that we call it benzene, can rotate in the matter of providing resonancy structure. So if the double bond switch in the other single bond, so instead of being here, it can come here. So if we imagine that every other single bond gets double bond, again we should have a triple bond in this structure. Okay, so these two are resonancy structures of each other. If you see, this structure is basically the abbreviation of these two structures. So they show it just as a circle, that these double bonds can rotate and be in between. It can be either here or it can be either here. It can be either here or it can be either here. It can be either here or it can be either here. So that's basically the resonancy, shows that these two have a resonancy structures, and shows that these bonds are not single or double bond. There are between a double bond and single, which is, we call it 1.5 bonds. I have talked about it in my previous videos called when I talked about the Lewis structure. So you can go back and watch that videos. Okay, guys, let's see how to name the benzene rings that have a branch on them. This is kind of the same as we talked about. It's just how you treat a branch on the regular chain of carbon. How you do that? You first just put the branch name and then put the root name of the compound. So we do the same for the benzene derivatives. We are gonna just put the branch, which we call it nitro, and you put the name of the compound, which is, we call it benzene. It's gonna be nitrobenzene. Also here is gonna be chlorobenzene. When we have only one substituent, we don't need to just number it because it's only one branch on it. Whenever you have a mono substituent benzenes, these are the names of them. So whenever you have a methyl group on the benzene, we call it toluene. Whenever you have an OH substituent on it, it's going to be phenol. OCH3 is going to be anisole. NH2 is going to be aniline. Whenever you have a COH group, whenever you have a CO double bond and H next to it, is going to be benzaldehyde. Whenever you have a COOH, is benzoic acid. We're going to talk about these later. Whenever you will see more of these. COH, which is carboxylic acid structure, COH, which is aldehyde structure, and NH2 when we have amine groups. Also OCH3 when we have esters. Also OH groups when we have alcohols. But for now, I want you memorize these structures. When you see these attached to benzene groups, these are the root name for them. Okay, these are the root name for these structures. When we should call a benzene group phenyl group. Whenever you use a benzene group as a substituent or branch, then we call it phenyl group. How? So let's look at this structure. I have this structure, and you can see that I have a chain of carbon, which here you see 4 carbon in a chain, and it can be 4 or more, 4 carbon or more carbon than 4. But here I'm just talking about the 4 carbon here. Whenever you have a benzene group attached to these 4 carbons, we call it phenyl group. Why? Because this benzene is now a substituent or branch of this longest chain of carbon that we found. This is called phenyl group. So whenever I want to name this, is gonna be a key of this longest chain. Do you remember when we have a key or branch is always written first? So it's gonna be 4 in the carbon 4. I have a phenyl group for phenyl, and in carbon 1 I have a double bond. It would be 1 butene. Why I named it from right here, because I have a double bond here. So that would be on carbon 1 a double bond, and on carbon 4 I have a phenyl group. As I said, it can be 4 or more carbons. When you have, you call the benzene group a phenyl group, and it's not necessarily should be a double bond here. It can be an alkane in the longest chain, or it can be even the triple bond in the longest chain. The important part is that we should have the longest chain. In the longest chain, we have 4 or more carbons. Even here, guys, I have this here, a cyclohexene, which is 4 or more carbons. Here I have 6 carbons. So it's gonna be this one, a phenyl group attached to the carbon 1 of cyclohexene. So it's gonna be 1 phenyl cyclohexene. So let's go, guys, whenever we have more than 1 substituents on the carbon. We already talked about when we have monosubstituent carbons, like this, and we said we should memorize them. What about when we have more than 1, like here as you see? Whenever, guys, you have more than 1, you should first see if you are familiar with one of the rooted ones that we already talked about it. You're gonna see if it's gonna be toluene, or it has a methyl group in it. Is it gonna have a OH on it? Is it gonna have OCH3 on it, or methoxy on it? Is it gonna have NH2 on it, or aldehyde, or COH on it, or COH on it, or not? If it has one of those, your root is gonna be based on one of these namings, okay? So your naming or your parent name is gonna be based on one of these. I will tell you now. For example, you have here, is any of these familiar to you? Yes, I have here CH3, right? So the CH3 always gets, because it's a root or parent here, because it's toluene, right? Is gonna, the one that makes toluene here with the benzene. So I should start naming with the numbering with number one here. And we go to the side that my other branches gets the lower numbers. So I go to the, from the right side, 1, 2, 3, 4. Pay attention, guys. I'm not gonna go from 1, 2, 3, 4, 5, 6 because my branches don't get lower numbers. So it's gonna be 1, 2, 3, 4. So the name would be, guess what? For coloro. Then when we want to write it down, I go based on alphabetical order. Is gonna be for coloro to nitrotoluene. 1 coloro, 2 toluene. What about this one? This one familiar to you, right? Is phenol, right? So we found the parent for it. Again, we start numbering. This one is going to be, doesn't matter from which side we start numbering. It's gonna be, because it's gonna be the same. So it's gonna be 2, 4, 6 tribromophenol. What about this one? Here we have ethyl benzene. So we start numbering from ethyl benzene. Is gonna be the root for us. 1, 2, 3, 4, 5, and 6 here. So it's gonna be, make sure when you write down but you should go based on the alphabetic order. So it's gonna be 2 bromo, 1 ethyl for nitrobenzene. Okay, let's talk about another way to write down the name of the aromatic compounds. Whenever you have two of the branches in the aromatic compound like benzene next to each other, we call it in the carbon 1 and carbon 2. Instead of just writing down 1, 2 dichlorobenzene, we call it orthochlorobenzene. Ortho. We make sure we write it down in the italic format. You can see it's in italic. Whenever the two are in the, you can see in 1 and 3, like 1, 3 dichlorobenzene, we call it meta, is ema italic. It's gonna be meta chlorobenzene. And when the two are in completely opposite side, is 1 and 4. So instead of putting just 1, 4 dichlorobenzene, we just simplify it perachlorobenzene, and P is gonna be in italic. Please pay attention, guys. These two not necessarily should be in the same, like both chloro. It can be one of them just bromo. So we just put, for example, if one is bromo, one is chloro, we just put in alphabetical order, just put, for example, para bromo chlorobenzene.